Now let's look at confidence intervals for the difference of two groups. So here are the conditions, same as before, for constructing a confidence interval about a difference in proportions. You have your random, 10%, and large counts. Just like in the previous video, we have to check these items for both groups. So both need to have two independent random samples. Their samples need to be less than 10% of their respective populations. And you have to check n times p and n times 1 minus p for both groups, and all values must be at least 10. A Harris Interactive survey asked independent random samples of adults from the U.S. and Germany about the importance of brand names when buying clothes. Of the 2,309 U.S. adults surveyed, 26% said brand names were important, compared with 22% of the 1,058 German adults surveyed. Let P sub U equal the true proportion of all U.S. adults who think brand names are important when buying clothes, and P sub G is the true proportion of all German adults who think brand names are important when buying clothes. Check if the conditions for calculating a confidence interval for P sub U equals P sub G are met. Okay, before we actually go into the conditions, I want to point out two things. Instead of doing P sub 1 and P sub 2, we've chosen here P sub U and P sub G. Knowing that I have two groups, one is the US and one is Germany, by using alphabetical letters U and G, I can easily understand which each of them is denoted for. When I look at P sub U, I already know I'm thinking of US. If I would have said P sub 1 and P sub 2, I'd have to think back, which one was 1 and which one is 2. So kind of using a letter from the actual name of the group can be helpful. Either one is fine. Second, we have P sub U equals P sub G. Why are they equal? The idea is we want to know if there truly is a difference. So we're always assuming they are the same, that there is no difference between the two groups, and we're trying to find convincing evidence that there is a difference. So, back to our conditions. We need to check that both are random samples. Well, it was told both were random samples of the 2,309 U.S. adults and the 1,058 German adults. Then, checking the 10% condition so that we can calculate standard deviation. Both samples are less than 10% of the population of those countries. Large counts. So we need to check n times p and n times 1 minus p, all four of them are all greater than or equal to 10. Now notice you still need to make sure you're using the correct notation, so that means the subscripts are quite important. Now to actually calculate the confidence interval. Remember on your formula sheet, we have statistic plus or minus critical value times standard deviation of the statistic. So now let's insert the proper notation for what we need for the confidence intervals and the difference of proportions. So your statistic is now the difference between the two sampling proportions, so p hat 1 minus p hat 2, plus or minus your critical value is still a z value, z star. Now the standard deviation, you have your formula, square root of p times 1 minus p over n, but then you have to add in the second one. Remember, we're going to be looking at the sampling proportions, so it's going to be the standard error that is used. So here we have all together the full-on formula. So far we focused on doing inference using data that were produced by random sampling. The following example shows how to construct and interpret a confidence interval for a difference in proportion for a randomized comparative experiment. Patients with lower back pain are often non-steroidal anti-inflammatory drugs, like naproxen, to help ease their pain. Researchers wondered if taking Valium along with the naproxen would affect pain relief. To find out, they recruited 112 patients with severe lower back pain and randomly assigned them to one of two treatments, naproxen and Valium, or naproxen and placebo. After 1 week, 39 of the 57 subjects who took naproxen and Valium reported reduced lower back pain, compared with 43 of 55 subjects in the naproxen and placebo group. Construct and interpret a 99% confidence interval for the difference in the proportion of patients like these who would report reduced lower back pain after taking naproxen and Valium versus after taking naproxen and placebo for a week. Based on that confidence interval in Part A, what conclusion would you make about whether taking Valium along with naproxen affects pain relief, and justify your answer? All right, so we have our 4-step process: state, plan, do, conclude. Remember, in the state portion, we're going to identify the confidence interval that we're doing. So 99% confidence interval for the difference of proportions. And then we need to identify our two proportions, P1 and P2. Or you could say P sub n, meaning they're going to do or P sub V, really. That means the naproxen and the Valium. And P sub P, naproxen and placebo, if you wanted to denote with a letter. Where one of the proportions is where they're taking both, and one is with the placebo. Then plan. So we're doing a 2-sample Z interval for proportion. So this is the name of the interval, and then we check our conditions. Both are random assignments of the patients, and then large counts, n times P, n times 1 minus P, and such would be all greater than or equal to 10. Now to actually calculate the confidence interval. So our first sample proportion is 39 out of 57, so 0.684, and the other is 43 out of the 55, 0.782. So filling in the values, so p hat 1 minus p hat 2. Then we have our critical value for Z for the 99% confidence interval, and then we have our square root. So once we've done all the calculations, we get an interval of negative 0.312 to 0.116. So our conclusion, we are 99% confident that the interval from negative 0.312 to positive 0.116 captures P sub 1 minus P sub 2, the difference in the true proportions of patients like these who would report reduced pain after taking naproxen and Valium versus after taking naproxen and placebo for a week. So based on our interval, what conclusion can we make about whether taking Valium along with naproxen affects pain relief? Well, because the interval includes 0 as a plausible value, we do not have convincing evidence that taking Valium along with naproxen affects pain relief for patients like these. Remember, we're saying that they are possibly equal, which means their difference equals 0. These are two ways of saying the same thing. So this is the claim that there is no difference. So if we get 0 in our interval, then we do not have convincing evidence that there is a difference between the two groups. If 0 was not in our interval, then we would have evidence to suggest there is a difference. So never suggest that you believe the difference between the two proportions is 0 just because 0 is in the interval. It's just plausible that there is no difference.